Hi, my name is Ricardo, and I'm a postdoctoral researcher here in RWTH Aachen University. It is located here in Germany. I was actually a little baby, and I was trying to learn my first steps and trying to walk around the house. I was born in the rural area of Colombia, and I always work in a farm. Since a kid, since I got a little present, which was a microscope, I was trying to check bugs and trying to become a little scientist, my mom said. And turns out I became a scientist. Industrial carbon pollution is a big issue. Since 1960s, we recorded 0.075 production of carbon dioxide dissipated in the atmosphere. Now, as of late, in 2019, we had 4.07 parts per million of carbon dioxide in the atmosphere. All of this due to the fact that we're trying to exploit fossil fuels, and in turn, we're producing a lot of carbon dioxide that cannot be reabsorbed by the atmosphere. We're trying to harness the power of tiny little molecules such as proteins. These proteins are able to capture as much as 10,000 molecules of carbon dioxide in as little as a second in order to produce carbonates that can be used for industrial purposes, building blocks, and even for bioenergy purposes. The challenge for my project is that these enzymes have to be able to be retrofitted into industrial chimneys. And there, the environment is really harsh, where temperatures are over 100 degrees Celsius and the pH values are over 10. So that's why I'm trying to engineer my proteins in order to come up with a better solution for them to inhabit this drastic environment. Currently, carbon capture technologies are only chemically based approaches that are non-sustainable, not economically friendly, and non-renewable. What we're trying to propose is to use a renewable system that doesn't alter with the environment and it can be disposed. So similarly to photosynthesis, we're using enzymes that can readily capture carbon dioxide in order to convert it into high added value molecules. In general terms, breathing cleaner air will be the ideal. We are trying to create a technology that is more environmentally friendly, not only for our generation, but for the generations to come, as well as trying to create a greener economy that has a better global carbon capture cycle that is not only reliant from our environment, but as well from our industrial emitters trying to capture their carbon dioxide and lowering tax breaks, creating new revenue streams for their companies, and as well creating a benefit for all the society as a whole. Trying to teach proteins to do something that they don't do normally or orchestrate them to do things outside the living cell is really complicated because they tend to do the production of the reactions that they need to do, but it's really difficult without the cofactors necessary within the living cell. What keeps me awake at night is trying to know if my technology can be upscaled to come up with better solutions for this big problem, which is the industrial carbon pollution.